We want to look at this question related to a geometric random variable, where we're told that qualified applicants have a 20% chance of being accepted into graduate school and top-notch programs. Assume a student's evaluations at different schools are independent of each other. You want to find the probability that you will have to send at most 12 applications to be accepted in one top-notch program. So you basically need to find the probability that you will have to send at most 12 applications until the first acceptance. And whenever you want to find until first success, you can use geometric provided you have independent trials, each with two outcomes with a constant probability of success in each trial. So let's see. So let's first define our random variable and let's see if it meets the conditions of geometric. So let the random variable x denote, because what we're interested in is the probability that he will have to send at most 12 applications. So we're interested in number of applications. So let the random variable x denote the number of applications that need to be sent until first acceptance. And the fact that we're talking about until first acceptance is what gives us a hint that we should use geometric. So how we define this random variable first? We've defined this. So this x is based on uh, this x that we defined is based upon the question statement, because the question wants us to find the probability you'll have to send at most 12 applications, right, to be accepted into one top-notch program. So based on this, given what we want to find, we'll define x to be number of applications that need to be sent until first acceptance. And the fact that we're looking at until first acceptance tells us to check if binomial, if geometric can apply here. So x in this case is a geometric random variable with p as its only parameter, which is the probability of success 0.2. Right? Because remember, geometric is always defined as the number of trials until first success. In this case, it's the number of applications until first acceptance. And why can we apply geometric here? Because we're already told his evaluations at different schools are independent of each other. So we do have the independence trials condition met. And then we also need that, in each trial, we just have two outcomes. And here, obviously, you can either be accepted or not accepted. So that's also met. And we have a constant probability of success. So all conditions of a geometric, which are you have independent trials, each with two outcomes, with a constant probability of success in each trial, are met. So we can apply geometric. And the biggest thing to applying geometric was until first acceptance. So now we want to find Now we want to find the probability x is less than equal to 12. Before we do this, right, here is something we want to note, right? So this is a note we want to make and then we'll find it. Let's note something helpful for a geometric random variable, an easy way to find its probability. Now this is only specific to a geometric random variable. Number one, the probability that x is greater than a is simply 1 minus p power a. How do I know this, right? Let's see. How do we know this? Now, the idea is that more than a trials are needed. In this case, more than a applications are needed only if are needed for first success, right? You need more than 8 trials in this case, more than 8 applications for first success. Sorry, for first success, only if first 8 trials were a failure. So that's why the probability that we need more than 8 trials for first success is just the probability that the first 8 trials were a failure. And we know the probability of success is p, so probability of failure is 1 minus p. And since all trials are independent of each other, so the probability of failure in the first trial multiply by the, so if you want to find the probability that you failed in all like first 8 trials, it's probability of failure in the first trial and the probability of failure in the second trial, so on really multiply the probability of failure for all 8 trials. So because they're all independent of each other, so that's why we're just multiplying the probability of failure of all the 8 trials, and that results in 1 minus p power a. The key thing to understand here is that you need more than 8 trials for the first success if the first 8 trials were a failure. So the probability of x is greater than a is just the probability that the first 8 trials were a failure, which means the probability first trial is a failure and second trial is a failure, so on till the 8th trial is a failure, right? And we can multiply the respective probabilities because of the independence, right? So, and what about if we want to find probability x is greater than equal to? Because we know for discrete random variable, the equal to sign matters a lot. So this is 1 minus p a minus 1, right? Because the idea is that you need at least a trial. So remember, with discrete random variable, you have to be very careful with the equal to sign, right? Need at least, here we need more than 8 trials. Need at least 8 trials. You need at least 8 trials for first success. Only if for first success, I'm sorry, only if first A minus trials were a failure. Only if first A minus 1 trials were a failure, right? So that's why the probability x is greater than equal to a is just the probability that the first a minus 1 trials of failure, so just 1 minus p power a minus 1. Remember, p is the probability of success, so 1 minus p is the probability of failure, right? So keeping this in mind for geometric random variable can be very helpful, and this can help find its probabilities way easier than actually computing them using its PMF, right? So just keep in mind, okay, probability x is greater than a is just simply 1 minus p power a, because you need more than 8 trials for the first success if the first 8 trials were a failure, right? So the probability that x is greater than a is just the probability that the first 8 trials were a failure, so is 1 minus p power a. You need at least 8 trials for the first success if the first a minus 1 trials were a failure, right? So this probability x is greater than equal to a is just 1 minus p power a minus 1, the probability that the first a minus 1 trials are failure. And with any discrete random variable, you have to be careful with equal to sign, right? So if we keeping this in mind, let's find our probability x is less than equal to 12. Right now, so for geometric random variable, let's just keep these two facts in mind. How do you find probability x is greater than, and how do you find probability x is greater than equal to, right? This makes it a lot easier to calculate probabilities for geometric random variables. So now we want to find probability x is less than equal to 12. We know we looked at probability x is greater than a, and we looked at probability x is greater than equal to. So let's try to write it in terms of either greater or greater than equal to, whichever is relevant. And for that, we'll use the complement rule. So probability x is less than equal to 12 can be written as 1 minus probability x is greater than 12, because we looked at that, we just noted over here that probability x is greater than a, 1 minus pa, and we looked at probability x is greater than equal to a is 1 minus p a minus 1, right? So we want to try to get probability x is less than equal to 12 into a form where we can use one of these that hold for geometric random variables. So we'll use the complement rule here and write it in terms of, because it's probability x less than equal to 12, so we can write it in terms of probability x is 1 minus probability x is greater than 12. So we've applied the complement rule here, which is probability of A is 1 minus probability not A. Now, what we can do is, we know probability X is greater than 12. This is, you need more than 12 applications. Only the first 12 applications were a failure, right? So we know the probability of success is 0.2. So probability of failure is 1 minus 0.2. So it's 1 minus 0.2 power 12, right? So the idea is that more than 12 applications are needed. More than 12 applications are needed only if for first acceptance, right? So you need more than 12 applications for your first acceptance only if first 12 applications were resulted in failures. Only if first 12 applications resulted in failures. Right, so this was really simple to calculate because we wrote probability x is less than equal to 12 using complement rule as 1 minus probability x is greater than 12. And then this we know, okay, we're just applying this over here. Okay, the fact you need more than 12 applications for first success, only first 12 were a failure. So the probability x is greater than 12 is just the probability that the first 12 applications were a failure, where we know probability of success is 0.2, so probability of failure is just 1 minus 0.2. And then you just do this as a 1 minus 0.2 power 12, right? Which is just the probability that all the first 12 application failure. The first is a failure, and second is failure, and third is a failure, so on till 12 is a failure. Because these are all independent trials, you can just multiply the respective probabilities, which just translates to 1 minus 0.2 power 12, right? So this makes it very easy to solve a geometric random variable question. Now, there's something that we do want to note here. Note. Right, there's something we do know, want to note here. Alternatively, we could have solved another alternative way. We could have found this without using the fact that probability x is greater than a is this, probability x is greater than equal to the a is this. Alternatively, we could have solved probability x is less than equal to 12 as we could have solved this like this, right? The probability x is less than equal to 12 is probability x is less than equal to 12 is the probability x is 1 plus the probability x is 2, so on till the probability x is 12, right? You know, for any discrete random variable, we can find up any probability using its PMF by summing up the PMF for those values of discrete random variable. And we know geometric random variable takes values 1, 2, 3, and so on, right? So probability x is less than equal to 12 will just mean x is 1 or 2, so on till 12. So we just sum up the PMF of x over all these respective values, right? So we'll sum up the probability x is 1 plus probability x is 2, so on till probability x is 12. But this is relatively tedious, right? Then just simply using this fact that we looked at for geometric random variable, but relatively tedious, right? So you could have done it in this way. So you would have just summed up all the probabilities from x 1 to 12 to find sum of the probability that x is 1 plus probability x is 2, so on till probability x is 12 to find the probability x is less than equal to 12. But this is more tedious and easier way to do questions related to geometric random variable are to keep in mind the probability x is greater than a is 1 minus p, because you need more than a trials for the first success if first a were a failure. And the probability x is greater than equal to a is 1 minus p power a minus 1, because you need at least a trials if first a minus 1 trials were failure. So using this, it's a lot easier to find the probabilities of geometric random variable.